Hey guys, welcome back to the channel. In today's video, we're gonna discuss about two of the most important instrument type transformers, current transformer and potential transformer. These transformers are very important components of a substation or say of the power system, and this two actually converts the high voltage and high current datas and step down those powers into smaller measurable form. So let's discuss about the current transformer first. What is a current transformer? It's a device which is used for the transformation of current at higher value to a lower value with respect to the earth potential. Here earth is an important factor. It is used with the AC instruments for measuring high value of current. Here I have the construction of a current transformer. As you can see, this is a single winding transformer. In the previous videos we have seen the transformer has usually two winding. Yes, it has two winding, but this is a special type of instrument transformer that has only one winding. In the primary and secondary, it has a same winding for that. So how it works is you have your primary conductor. You take one phase out of three phase, you take only one phase and you pass through a city. This hollow core, this ring type thing, this ring, this is a hollow core, and you pass your main conductor through it. Your main conductor will have um, voltage up to like 220 volts or current up to take 16 ampere, 32 ampere, even more. It will, and this hollow core, there is a winding. This winding, it's wrapped around the one part of a core, and due to the electromagnetic induction through the main conductor, it will induce current in this one, and it has a, this is a step down type, and the current over here is measured through an ammeter. You see, so CT is a kind of transformer that pairs up with the ammeter to form a single unit. And you see I have the symbolic structure over here, and from you see there's the main primary conductor, this one, and a winding is wrapped around the primary conductor, which is for the secondary one, and it is further paired with an ammeter to complete the circuit and measure the current through the primary conductor. So this is basically what a CT looks like, and here I have the points. The primary of the current transformer is connected directly to the line whose value is to be measured. So this is the primary, and CT doesn't have a winding like primary. This is the same conductor from which we want to measure the current, and it is directly taken as the primary, and it has only the secondary winding around this toroidal hole structure. The secondary of the CT is connected to the ammeter or a meter which measures the line value regarding the function. We want to measure the current in the purpose of CT is to measure the current. So Here our purposeful meter is an ammeter. Of course, ammeter measures the current. Nowadays digital emitters are there. So we connect a ammeter or a digital meter to measure the voltage across this, measure the current across this line. The current transformer produce an output in proportional to the current flowing through the primary winding as a result of a constant potential on the primary. The primary or the main conductor has very high values of current or voltage flowing through it, but we want to measure current, so taking current as our value fraction, what CT does is it step downs the current to a proportional one. You take like 1 is to 32 or like 1 is to 16, like that. It converts the current into some proportion and gives us the value. There are three basic types of current transformers. These are own type, toroidal type, and the bar type. Let's check what these three types look like. The own type current transformer. The transformer prime The transformer's primary winding is physically connected in series with the conductor that carries the measured current flowing in the circuit. The magnitude of the secondary current is dependent on the turn ratio of the transformer, of course. If the turn ratio, it's a giving a proportional current to the main one, so if the turn ratio is less, the proportion will be greater, and that if the turn ratio is more, the proportion will be smaller. For like if I have like more number of turns over here, I will get like 1 is to 4 or 1 is to 10, 1 is to 16, and as you decrease the number of turns, you already know it will work as a step down one. So the more number of turns you decrease, the less current it will show, and the proportion will gradually increase. Here we have the toroidal current transformer. How a wound current transformer looks like is, this one is an wound current transformer, and now we are discussing about toroidal current transformer. This do not contain a primary winding. Instead, the line that carries the current flowing in the network is threaded through a window, or you say a hole, in the toroidal transformer. Some current transformer have a split core which allows it to be open, installed, or closed without disconnecting the circuit to which they are attached. So, in say in the wound type current transformer, you can never open the CT whether it's connected or not. But in the toroidal transformer, you can keep it like disconnected, the secondary part, whether you have connected it to the circuit or not. And also you can connect it to the circuit without disconnecting the secondary as well. So there's another type, that's the bar type current transformer. In this type of current transformer uses the actual cable or the bus bar. You see, the in the substation we call the actual cable as bus bar of the main circuit as the primary winding, which is equivalent to a single turn. Of course, like one single cable is equivalent to a single turn for the primary. They are fully installed from the high operating voltage of the system and are usually bolted to the current carrying device. So here you can see, in the bar type current transformer. These are the most commonly used in high voltage circuits like say substation or the sending substation or receiving substation. This is the most common one, and which are actually used, and these two are mostly used in low voltage, but this bar type is used in the high voltage one. Here you have a bolted primary. This square bar, the solid square bar is a bolted primary. What you do is you bolt the main bus bar directly to this square bar. Yeah, here you have screw gaps, these holes, and you bolt it to this square bar, and you need a single line. So you bolt the incomer one here, and the one which is gonna travel far away, you bolt it over here. So this works as a stationary one, and this square bar is equal to a single turn. You This is of course the primary one, primary for the city, and this works as a single turn itself. And the other the secondary one is inside this one. There's a hollow core, and this bolt passes through the center, and the second one, the secondary one, is wound through the hollow core. Generally, a current transformer of say like 500 by 5, it's a ratio. You see, will produce 5 amps in the secondary for 500 amps in the primary conductor. That is 100 times greater, right? So this is the ratio. You see, like 500 amps of the primary winding, like primary is connected to the bus bar. So bus bar has amps of 500, and the secondary produces like 5 amps. It's 1 is to 100. It's a big ratio, right? Now talking about the potential transformer, that is PT. It's a voltage transformer. CT generally like used to measure the current into ratios. Like we don't have those emitters that measures like 500 of amps. That's a great value. So we have to step down this to a measurable form to like 5 amps, 10 amps, 16 amps, right? So this is where CT comes handy. And for the potential transformer, it's a voltage transformer, and it is a type of instrument transformer, of course, which is used for the transformation of voltage from a higher value to a lower value, same as a current transformer. But in this case, the voltage is being transformed into a lower value, or you say like a measurable value. So here I have the line diagram, symbolic representation of a PT. You see, this is the supply, the and the PT structure is same as our basic transformers. It has two windings, the primary one, the larger winding one, and it of course is step down. So in the secondary we'll have less number of winding. So you see here we have one, two, three, four number of windings, and in the secondary we have two winding. So it will basically step down from like 4 is to 2, or say like 2 is to 1 ratio. So in the secondary part we have the voltmeter to measure the step down voltage. The primary terminal of a potential transformer is connected to the line for measuring the line voltage. So this is the supply, and from supply we are getting two lines, and from here tappings are taken for the Potential transformer. The potential transformer reduces the high value of voltage into small value which can be easily measured using voltmeter or say any meter. The PT in general are shell type transformers. If you want to know what are shell type transformers, you can check the transformer previous video in the series. These are basically shell type transformers, except the load on PT is like very small, a few volts. So if you take another shell type transformer of the same class but not PT, it will have a heavy loading up to maybe up to like kilovolts, megavolts. But in PT, it's like few volts and few amps. The PTs are used to measure high voltages that are also used to operate relays in the power system. So you already know what are relays. These are small electromagnetic devices that used to cut off a circuit or trigger the switching operation automatically up to some threshold values. Right. For safety, the secondary is completely insulated from high voltage primary and also grounded. You see, the secondary is grounded over here. So the ground connection acts as an isolation. You see, like in the primary, we are having very high voltages, but in the secondary, we are taking a voltage which can be measured, not like 5 kV or like 500 megawatts or something. So we are converting it into low voltage. So in the secondary part, we are having a circuit which only tolerates low voltage. So if some surge from the primary side come, so this might like burn out the secondary part. So grounding is done to prevent this thing, and the secondary part is completely isolated from the primary side, and this provides protection to the operators as well, those who work or measure or the maintenance staff. Normally the secondary voltage is rated up to 110 volts, which is still measurable. The PTs are basically a step down transformer. You should keep this thing in mind. The primary side has large number of turns and the secondary has small number of turns. This is the feature of a step down transformer. A shell type construction is suited to PT as they give more accuracy. The PTs are up to like 6.6 kV, and these are dry type transformers and their higher ratings like up to 6.6 kVs are generally dry types, and if you take PTs of higher rating more than 6.6, these are usually like oil immersed for the cooling purpose. So we already know we have three types of cooling, like the dry one, the oil one, and the forced air one. So this is a figure I have. It is a two winding single phase potential transformer. You see we have two windings over here, like this two form one and this two form one. Okay, so this is a two winding potential transformer, and you see this one is more than 6.6. This is the example of 6.6. This is an example of more than 6.6 kV transformer, and here we have the core over here, and the oil stays above the core to cool the core. Okay, and here we have the high voltage bushings and all. For the comparison part, I'm gonna suggest you the Circuit Globe website. They're actually giving the best comparison chart for a current transformer and a potential transformer. So basically here the definition, starting from the definition, a current transformer transform current from high value to low value, and in the potential transformer, the voltage from high value to low value is transformed from high value to low value to a measurable voltage for say like up to 110 volts. Here we have the circuit of CT. It's a line diagram basically, and here we have the PT. This is the same as a traditional transformer. The core, taking the core of a current transformer, it's usually built up with laminated of silicon steel. The core is the toroidal core. The round one is say the toroidal one, the round one, right? The round one is made of silicon steel. It's basically laminated. Why it is laminated? To, of course, reduce the eddy current losses. And in case of potential transformer PT, it is made up of high quality steel operating at low flux densities. The high quality steel is also done used to reduce the flux, and these are already operating at low flux densities, right? So it reduces the leakage flux. Talking about the primary winding, it carries current which is to be measured. Of course, the CT, in the case of CT, the primary is itself the bus bar, itself the conductor, and in case of potential transformer, the primary winding carries the voltage which is to be measured, and this is not the conductor. From the main conductor in case of potential transformer, tappings are taken to the primary side. Talking about the connections, uh, CT is basically connected in series, and the PTs are connected in parallel to the bus bar. And here we have for the primary circuit has CTs has small number of turns. Like say if you are passing in case of CT, you are passing only one conductor, so it will act as a one number of turn. And in the seat and the PT, there is a large number of turn as it is a full size step down transformer. In the secondary circuit, in case of CT, has large number of turns, and this cannot be a open circuit, because if it is connected in series and if you keep the secondary of a CT open, it may cause fire. Potentially, it may explode also. So there's a high risk in case of CT if you keep it open, as CT acts like an step up transformer. Basically, the primary has one turn and the secondary has more number of turns, so it's basically acting as an step up transformer, and it is actually increasing the voltage in the secondary part. So if you keep it open, you may see arcing will heat up the terminals, which will cause rise in temperature and eventually lead to fire risk. The range of a CT is from 5 amps to 1 amps, and in case of PT, these are generally up to 110 volts. The transformation ratio of a CT is very high, but in case of PT, it's a low transformation ratio. Okay, so you can check the other points as well, like the impedance points. Like CTs are types. Here we have two types of CTs given by the circuit globe. They are they mentioned about wound type and closed core type. Basically, only these types are required. But if you See, I have mentioned earlier there are three types of CT: the wound type, closed core type, and the toroidal type. In the electronic circuit, you will see the toroidal types. So those are current transformer as well, and these are basically used in the SMPS of a computer CPU or an inverter system. So those are also current transformer, those toroidal types. And in the case of PT, there are two types of PTs: the electromagnetic and capacitor voltage type. And here you have the impedance, like CT says low impedance and PT says high impedance. And the applications, you can take it from here: the measuring current and the power, monitoring of power system grid operation, and also for this CTs act for operating protective relays. Protective relays are those which disconnect the operating side from the high voltage side. And the PTs are used for measurement. These are also used as a power source. Actually, in the operating side, the power required is typically very low to run our devices. So those like 110 volts can be also taken from the PT itself to run or power our appliances in the operator side. And this does work as an operating protective relays. Okay, so this video is all about the CTs and PTs, the two most important types of instrument transformer. So if you enjoyed the video, give a thumbs up. Comment section is all yours. I will give a link to the article of Circuit Globe in the description of the video.